Hello everyone, today we'll be continuing with the previous video on PCOS and we'll be looking at the significance of this new technological innovation involving the use of GAN and data amplification for AI diagnosis of PCOS by examining the success of its test trials and importance of further application in the medical diagnosis field. But before I proceed any further, I'd like to clarify that from this point on, since this presentation was a group project, I didn't necessarily write the section, someone else did, but again, I'll be explaining this in my own words. Okay, now with that said, let us proceed. AI has made diagnosing lean PCOS much more accurate. According to Marie Mumji, traditional methods of analyzing pelvic ultrasound images have an accuracy of around 60%. Now, this is because the task itself is very difficult. Analyzing many black and white images requires intense focus, and even small mistakes can lower accuracy. The AI model we studied, however, achieves a 90% accuracy, reducing the chances for errors and even providing more reliable results. AI also speeds up the whole diagnosis process. A study from the Wiley Online Library found that AI can reduce the time spent analyzing images up to 65%. Now, this helps doctors intervene earlier, which may lead to better outcomes for patients. This is because, although PCOS is largely untreatable, and this may make you wonder, then what are the benefits of early detection? The undiagnosed PCOS can perhaps lead to progression in more severe stages, which can then lead to conditions such as endometrial hyperplasia, characterized by thickening of the uterus wall, or even uterine cancer, which involves surgical procedures entailing costs and health risks. However, there are certain limitations. The AI only shortens the time for analyzing the images, not the entire diagnostic process. For example, many patients take years to notice the symptoms and even decide to visit a doctor. According to the National Library of Medicine, this delay often ranges from 2 to 5 years, so even with AI implementation, diagnosis itself can still take a long time. Another issue is variability. Follicles oftentimes differ in size and shape between individuals, and if the AI encounters images that are very different from the data that it's been trained on, the accuracy can suddenly drop. This means the model needs regular updates with the new ultrasound images in order to stay much more effective. Ethical questions may also rise up. For instance, if an AI gives an incorrect diagnosis, who is ultimately responsible? The developer, the doctor, or even the system itself? There is also the issue of bias if the AI was trained on an incomplete or an unbalanced dataset. Now, these challenges need to be addressed in order to ensure the AI is safe and fair to use in healthcare. Lean PCOS is also a good example of how hard it is to diagnose certain forms of PCOS under the current medical standards. Doctors are more likely to check for PCOS if a patient's BMI is high, but with people for lower and normal BMI levels, it is oftentimes overlooked due to the social bias. Now, this bias and preconception that PCOS patients have a high BMI level has real-world impacts. Financially, undiagnosed or misdiagnosed PCOS can lead to higher healthcare costs later on because the disease can proceed to result in severe conditions like, for instance, uterine cancer, as aforementioned, for example. Socially, people with conditions like lean PCOS can even feel ignored or unsupported, adding to their stress. Now, while AI itself is a promising tool to improve accuracy and speed in diagnosis, it is not a complete solution. Doctors still need better training and awareness for all types of PCOS, including lean PCOS. Education is also key to improving diagnosis, reducing long-term costs, and ensuring that patients are getting the care that they need. And this brings us to our ultimate conclusion that equity in healthcare starts with awareness, and only by recognizing the diverse faces of PCOS can we ensure accurate and compassionate diagnosis for all.